So this is another question, and you are asked to find the transfer function. Okay, so if you have to find the transfer function, okay, so what you should know before you start, so we got the first loop, second loop. There's also another loop at the back, but we're not gonna consider it. So we're going just to stick to the two loops that we can see. So this one's the first one, and that one is the second one. Okay, and the input, this is where we have our input, it's v1, and this is where we got our output. And you should know that the transfer function equal to the output. Okay, it's gonna be the output over the input. This is the formula of the transfer function that we need to find. Okay, so now what we do, let's start with the first loop. Okay, let's break it down and see what we can get from there. So it's gonna be v1 of t equal, so the voltage across equal to the sum of the voltage inside the loop. So we're going to have a voltage across this inductor, another voltage across this resistor. So we're going to add the voltage as we get there. Okay, so it's gonna be Vn of t plus Vr of t. Okay, this is what we get from loop 1. And if you want to check for loop 2 at the same time, okay, so we're actually going to get something like this. So it's gonna be v2, so it's gonna be just the same principle, the sum of the voltage across equal to the sum of the voltage inside the loop. So it's gonna be the voltage there, since they are in parallel. Okay, so we're going to get Vr of t. Okay, for the second loop, so it's gonna be the voltage that you see here equal to this voltage. Okay, and for this one, it's gonna be the sum of this voltage plus the voltage that you see there on the first loop. That's what you see there. So let's just carry on, and then from here, if you want to solve to get the transfer function, you can automatically take this and place it inside the transfer function. Okay, so if I want to solve, for example, for the transfer function, I can just plug the value there, or otherwise, you remember, you can write it in this way. So it's gonna be R. Okay, if you go back to this table, okay, this table here, it's the one that I'm going to put there, so then we can have an idea of what we can write inside this okay, so it's gonna be this one times R, and if I want to go further, and remember, since this one is loop 1, so the current is gonna be, I'm going to write it in that way. So, and for the second loop, we'll get V2 equal to I t, so it's gonna be subscript 2 times R. Okay, so we're gonna have another current through that resistor, and then you can write your transfer function. So in my case, if I want to write the transfer function, I have two ways of writing the transfer function. So let's just stick to the easiest one. It's gonna be v2 of t over v1 of t. So it's gonna be the equation that you see here. Okay, it's what I'm gonna put on the bottom, and the message, the circuit, the equation that you see on V2, I want to put it at the top. So this is our transfer function, and if you want, you can go further and solve for the transfer function, or maybe we can use the formula that I just mentioned here. And also pay attention that you need to solve for the current, depending on the current that you're gonna get across the resistor, across the inductor, and in this line. So it's gonna be maybe we're gonna see an example where we have defined the direction of the current and you can apply Kirchhoff law. So this was just to give you an idea of how you can solve for the voltage in this type of equation.